Today's revision video is on Pure Unit 2 looking at circles and triangles. The question here, I'd recommend that you pause the video, get the question written down, get the diagram drawn. It says the points A, B and C lie on the circle as shown in the diagram, and we want to first of all show that AB is the diameter of the circle. So we want to show that the line AB is the diameter of the circle. Now, this is going to incorporate one of our circle theorems that you saw at GCSE, and that theorem is that if we have a triangle inside the circle, where the base of that triangle is the diameter, then the angle at the circumference must be 90 degrees. We're going to use Pythagoras to show that AB is the diameter of the circle. So we're going to find the lengths of each side of the triangle, show that Pythagoras applies here, which will show that that is a right-angled triangle. So I'm going to first of all find the length AB. I'm going to be using the distance between 2 points formula here, which is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, if we actually square both sides of this formula, we get that d squared is equal to x2 minus x1 squared plus y2 minus y1 squared. I'm going to use this version of the formula because I'm using Pythagoras. I'm going to be squaring my side lengths anyway. So I'm going to first of all look at AB squared. So that is equal to 4 subtract negative 8 squared plus 5 subtract 1 squared. So I've used x1, y1, x2, y2. This is equal to 12 squared plus 4 squared, which is equal to 160. So that is the hypotenuse of my right-angle triangle, if it's right-angled. I'm now going to find the shorter sides. So AC squared, that is equal to negative 4 subtract negative 8 squared plus 9 subtract 1 squared, which is 4 squared plus 8 squared, which is 80. And then finally, we're going to look at BC squared. That is equal to negative 4 subtract 4 squared plus 9 subtract 5 squared, which is negative 8 squared plus 4 squared, which is 80. So we're going to add AC squared and BC squared together, which is 80 plus 80. That is equal to 160, which is equal to AB squared. We then need to write a statement to conclude our answer. We would say that Pythagoras' theorem applies so angle ACB is a right angle and AB is the diameter. For part B, we're asked to find the equation of the circle. So we know that an equation of a circle is of the form x minus a squared plus y minus b squared equals r squared, where AB is the centre and r is the radius. So we need to find out the equation of the coordinates of the centre and the radius. To find the coordinates of the centre, if we look at our diagram, the centre is the midpoint of AB, because we've just found out that AB is the diameter, so the midpoint of the diameter, that must be the centre. So we're going to find the midpoint of AB. I'm going to call that N. We're going to use our formula for the midpoint, which is x1 plus x2 over 2, y1 plus y2 over 2. So we've got negative 8 plus 4 over 2, 1 plus 5 over 2, which is negative 2, 3. So we found our centre, we now need to find the radius. Now in part A, we found out that the diameter squared is 160. So the length of the diameter, or the length AB, must be the square root of 160, which is 4 root 10. We know that radius is half of the diameter, so the radius must be 4 root 10 divided by 2, which is 2 root 10. So we're going to put our radius and our centre into our equation of a circle. We're going to use x minus a squared, so we're doing x, the negative version of negative 2, so we're doing x plus 2 squared plus y minus 3 squared. That is equal to the radius squared, so that's equal to 2 root 10 all squared. Now 2 root 10 all squared, that is equal to 40. So our equation of a circle is x plus 2 all squared plus y minus 3 all squared is equal to 40.